This is lecture 8, an example. So this is kind of a long example, but we're going to get it done, hopefully fit it on one screen here. And we've been looking at subroutines and kind of the important part of issuing those, which is kind of stack control. So let's go ahead and look at this example. And some overhead first. Look, so I'm going to write a subroutine. Generally speaking, it has a header with all sorts of good information in it, like a description, name of the subroutine, arguments I'm sending, and return values. But we're going to skip that. This takes too long to write. But what we're more interested in is the initialization code right here. And essentially, if it's a nested subroutine, I need a return address. I need to save that return address on the stack. For this, typically I'm going to need to save the context, which is saving the registers that subroutine uses, and then set some working values also. So usually it's like loop counts and stuff like that, set accumulators, typically what I do. Then I do the subroutine, and then I essentially undo these two things here. So I restore context, certainly restore the return address if I had to save it, and then I return. Okay, so everything's going to look like that, and so let's crank this through. Yes, push and pop is the way I'm going to save the context. When I enter a subroutine, I'm going to push all the context, which is the registers I use on the stack, and then when I leave, I'm going to pop them off the stack. Particularly if I have nested subroutines, and this example has a nested subroutine in it. When I nest subroutines, I have to store the return address also, and we'll go over that in this example. So this example is, right, a subroutine that calculates combined parity of 5 words starting at some address in memory. So essentially I'm going to store the parity in x30, and the key here is don't permanently change any registers other than x30. So x30 essentially is going to have the return value in it. So I'm going to want to save every other register I use except for x30. Now the key to this problem is to remember that we did an example like this, and let's go down to it. Okay, here's the example. This is the solution I think as we did it. Now the problem with this solution is it's not bulletproof. I didn't save the context in this thing. And so I was trying to save space, and it was kind of one of the first things we did. This was the classic one where I forgot to shift it, forgot to divide by 32 at the end. But anyway, so the point being that is I don't want to mess around with this problem. I want to make it work without thinking about it. So I'm rewriting this parity subroutine to be bulletproof. And so what essentially is the same subroutine, except I saved context. So this register, what I'm interested in here is the notion that it's putting my my parity into x20. The return value is x20, so I need to remember that. But anything else I don't need to worry about now, because it uses x10 and x15 in here. Also uses x20, but that's return value. So x10 and x15, I've pushed it here, I've popped it here, so I've saved context here, I restored it here. Now I can use this subroutine without worrying about having it stepping on registers from my calling code. So we're not going to rewrite the subroutine, but we are going to call it. And so let's look at this thing. It's going to be long. Okay, so very first thing I want to do in this problem is it's a flow chart. I've been trying to be a good citizen here. Oh, let's call it something. Par 5. And a couple things I want to do here is save context. I know I have to do that because it told me not to permanently change any registers other than x30. I've got to init stuff. There's going to be a loop in there. I have to do this 5 times. Also, it's accumulator too. I have to initialize accumulator. And then it's just a normal loop there. I like doing these as a while loop always works good. Okay, so is count 0? Yes, this is the end of the loop. And so once I get out of here, I am going to need to mask that final value. Essentially, I'm going to be calling parity 5 times in this thing. And then I need to essentially undo the save context, which is a restore context. And lastly, do I need to do anything else? I don't think so. I think I'm done at that time. At that point, there's a return. So let's figure out if it's not 0. What am I going to do? This is a no. I'm going to get some data. Once I get that data, I am going to call my parity subroutine. There's my special box for a subroutine. And after that point, I'm going to do some loop admin, which is going to be essentially just the pointer, and then I'm going to adjust the loop count, and then I'm going to feed it back into there. Okay, looks good on this. Okay, so this is going. Let's crank through this thing, and the issue is I gave it a name here. I called it par 5 for lack of a better word. And so I am going to start implementing this thing. So first thing here I'm going to do is save context, but I absolutely don't know what context I need to save other than the return address. So I don't know which registers I'm going to use yet. I'll figure that out when I'm done, and so I don't have to worry about it. And so I always put a init label in here. I'll leave that there, but I'm going to leave some space up here and put my subroutine right here. So that's the save context. I don't know what I have to save, but I'm going to also initialize some stuff. And so arbitrarily, I know I need a loop counter in there. And so I'm going to say load immediate. I can use anything I want. So I think I will use, I don't know, x16 sounds good. x16, put a 5 in there. That's my loop count. And I also have an accumulator in there. So I need to move a value into accumulator, which is going to work out to be x30 on this one. It works out great. Now, x0. Okay, so that looks good. Got that box, and this is going to be a normal loop, a while loop. So I'm going to call this BEQ x16 x0, and I'll branch down to done. And I think I'll put done right here. I always put the label in after I put a label so I don't forget it. And I think this is good for this box. So right here I need to get some data. And so that's going to be a load word of data. And I'm going to load it into x10. And I'm going to get it from memory starting at the address of x25. And that was given to me in the problem. Okay, so I chose x10 for a reason, and the reason is I'll scan forward to it here. The reason is the subroutine. Oh, I guess it doesn't. It should be x20. It puts the result in x20. Okay, I got that right. So let me go back up here, change this. The result goes into x20, and so that's going to be what I'm going to send to the subroutine. So I'm loading it from memory into x20, and then I can call the subroutine. That's not right. I looked at that wrong. It's x10. So x10 is getting the value. So essentially, this is the thing I'm looking at is x10. Okay, I had it right the first time. Let's do that. Can change that. Yeah, I'm not the world's best coders. I mean, I eventually get it right, but it's always kind of rough at first. Okay, so there's call parity. Once I got that right, and what else do I need to do here? Okay, so the result is going to be returned in x20. The parity is going to be returned in x20. It's x20 upon return from this thing. And so what I need to do next is essentially add x30 to x30. This is accumulation to x20. Now x30 is my accumulator up here. I'm just adding the parity bit to it. And I think that's it. So there's the call parity. And I do need to do some loop admin. I'll put a label in there just because I like putting it in there. What I'm going to have to do in this thing is decrement the loop count. Add immediate x 16 x16 minus 1, and I also need to advance the pointer, which is at x25. Since I'm working with words here, it's going to be an add immediate x25 x25 and 4. I'm working with words. Okay, so lastly here, that's this box. I can go back to my start of my while loop. So that's jump into loop, and that's loop. Okay, so that's most of it right there. If I break out of this thing, I can come down to this done, which I essentially need to implement this now. So I'm going to go ahead and erase that and move it up because I kind of need that space. So this is done. At the done, I am going to mask this thing. And the masking I want to do here is everything except the LSB of x30, which is my accumulator, and immediate x30, x30, and 1 that preserves MSB. So that's going to be my a parity of all 5 bits put together. Okay, so that's that. So now I'm at the point where I need to save and restore context. So if I look at this thing, I'm looking at the registers I'm using in here. So I'm pretty much using every register except x30. So that's going to be x10, x16, and x25. x10, x16, x25. So I'm gonna go ahead and that's 1, 2, 3. That's 3 registers. But I also need to save the register x1, which is return address, because I have a nested call in this thing. So I need to save space for 4 registers in this thing. So that's the first thing I'm going to do right here. Add immediate. And this is going to be SP minus 16. Okay, that's going to save space for 4 words, so 16 bytes. That's where the 16 came from, 16 bytes. And so let's do this. I'm going to store. I always do this really fast. Store. What am I going to store? X16, X25, X10, and a return address. Okay, so there's 2, 3, 4. Where am I going to store it? 0, 4, 8, 12. This is stack pointer, stack pointer, stack pointer, stack pointer. Okay, so this is the act of saving context, pushing 4 values, 3 registers plus return address, which is a register also, onto the stack. So that's this box. Notice I did it. I didn't know what I didn't know what registers I was using. So I had to wait. I had to do this at the end of writing this thing, not at the beginning, because I don't know what I'm going to use. Okay, so on the end of it, I need to restore context, and it's going to be very much the same. Load word, load word, load word, load word. I'm just looking at this thing. I'm just doing the exact opposite. If I was actually working on a keyboard, I'd actually be done now because I could cut and paste the thing. This is going to be 0, 4, 8, 12, SP, 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 SP. And lastly, I need to undo that stack pointer, which is add immediate, SP, SP 16. So this 16 here undoes this minus 16 right there. And with that, I think I'm done, except a return. And at that point, I'm going to call it done. And so a little bit confusing in the middle there. If I had documented it a little better, like had better comments on the, like a header on this thing, I wouldn't have made that ugly mistake in the middle. So yeah, once you start looking at these things, it's just, it looks like a foreign language after a while if you don't know what you're doing. Okay, so roughly speaking, here's the solution. Here is a solution. I believe it's roughly the same thing. I probably used different register values. Not a big deal. But the important thing is if you look at this code, it looks like, oh my God, this is a ton of code. But I want to kind of try to convince you, don't be intimidated by this code. So the issue is you break it down to little boxes and it's not that bad. So let's do it. Here's essentially, here is a loop. Here's the loop administration. This is pretty much the body of the loop. That's the only thing that's really happening in this program. I've got some initialization stuff for registers and a loop count, etc., not a big deal. This big chunk of code. Okay, so my microphone was cut out on me. I don't know why, so hopefully I can just tuck this in here. But what we're doing is kind of convincing yourself, although this looks like a hell of a lot of code, it's not that bad. Once again, we save context, restore it, practically the same code. I cut and paste it when I'm doing it on my own. This is little bit of sequence statements there, not a big deal, and a while loop stuck in the middle of it, some initialization code. So if you break this down into little parts, it's very doable. It's not a big chunk of code. And so once again, this is saving context, restoring context, something you do over and over again. Once you do it a few times, it becomes second nature. And the second thing here is, this is just a typical while loop, not a big deal. You'll be doing a lot of those. Once again, it's the same stuff over and over again.